Good morning, students. So this is the continued part of topic chemical kinetics. Okay, where we were there, we were at the types of reactions based on the order of the reaction. And in the last class, I have just taken you four types of the reactions based on the order. First one, zero order, first order, second order, third order, and fractional order. Now in this class, I will solve some more types of the reactions. That is, 5 types I have covered in the last class. Now sixth one, types number 6, pseudo first order reactions. This is an important one, and it will be asked for 2 marks with examples. Okay, so pseudo first order reactions. These are also called as pseudo unimolecular reactions. So here, pseudo first order means these reactions are actually of higher order. They are converted to first order so that under certain conditions, higher order reactions can be converted to first order, are called as pseudo first order reactions. Or another definition is that the reactions with molecularity greater than 2 but follows the order 1 are called as pseudo unimolecular reactions. So I will give you the definitions. These are the reactions that are not truly of first order. These are the reactions that are not truly of first order, but under certain conditions become reactions of first order. Okay, this is the definition of pseudo first order reaction. Another definition is that reactions of higher order are converted to first order by taking one of the reactant in a large excess quantity. Okay, this is another definition of pseudo first order reaction. So that in the pseudo first order reaction, so here features of pseudo first order reaction I will give you. In the features, first feature will be the molecularity is in these reactions molecularity will be greater than 2 but follows first order kinetics. Molecularity will be example, inversion. First one, inversion of cane sugar, inversion of cane sugar, or hydrolysis of sucrose. So this is the first example. The reaction will be C value H22O11. This compound is sucrose and it is optically active. Optically active means it will show the plus rotation or clockwise rotation of plane polarized light, plus H2O in presence of H plus, giving rise to C6H12O6 plus C6H12O6. One of the molecule is glucose, another molecule is fructose. See here, if you take the concentration of all the three reactants, sucrose, water and catalyst, this will be of third order reaction. Actually it will be of third order reaction, but water H2O is a solvent. It is present in large quantity, so that concentration of water remains constant throughout the course of the reaction, and order with respect to water becomes zero. So this reaction rate law can be written as rate law is equal to R is equal to K into sucrose raised to 1, H2O raised to 0 and H plus raised to 0. Because H plus is a catalyst, means we are taking the reaction in the presence of a dilute acid, and the concentration of H plus will remain constant. So order with respect to H plus is also 0. Therefore, overall order of the reaction will be 1. Okay. Actually, if you see the reaction properly, it will be of higher order reaction. That means 1, 2, 3, third order reaction. Okay. And in the actual conditions, what happens? The concentration of water is a constant, because water is a solvent. It is present in large quantity, so that order with respect to water becomes 0. And second example, I will solve here. Second example. Example number 2. Hydrolysis of ethyl acetate. Hydrolysis of ethyl acetate. Hydrolysis of ethyl acetate. So here CH3COO C2H5. This compound is called by the name ester, plus H2O in presence of H plus, giving rise to CH3COOH plus C2H5OH. Okay. So if this is the reaction, here in this reaction, let me give one small illustration with a value. Okay. So here at time t is equal to 0, let us say 0.01 moles of ester has been reacted. At that time we have used 10 moles of water. At the time of 0, so that products will be 0. Okay. As the time passes, and after say 15 minutes or 20 minutes, time with t, then so this will be 0. Okay, this is 9.9 and this will be 0.01 and 0.01. So simple calculation. What is the simple calculation? Initially in the reactant 0.01 moles of the reactant is present and 10 moles of the water is here. Okay. At the same time, product formation is 0. Okay. And after time t, that is say for 15 or 20 minutes, the reactant concentration reduces to 0 as reactants are consumed to form the products. Okay. And water concentration next category, seventh one. So here I will end the pseudo first order reaction. Okay. Next one, complex reactions. Complex reactions. So generally seventh category, complex reactions. Generally, rarely a reaction will be completed in only one step. That means in the elementary step. The reaction which is completing in the single step are called as elementary reactions. Okay. The reaction which is taking place in two or more steps are generally called as multi-step reactions. Multi-step reactions or complex reactions. Generally, hardly a reaction is completed in the single step. Generally, a reaction which is completed at the single step, we are calling it as elementary reaction. So, the reaction which is completing in two or more steps, that is more than two steps, is called as multi-step reaction or complex reaction. What is the special in these complex reactions? So here in this is the method. In these reactions, one of the reaction step is slow. Okay, and this slow step is deciding order of that reaction and overall order of the reaction. So in these complex reactions, one of the steps is slow and it is deciding order of that reaction and overall order of the reaction, and is called as rate determining step. So that if there is a complex reaction, then what you have to concentrate? You have to concentrate on slow step of the reaction, which is called as rate determining step, and it will decide overall order of the reaction. Let me give one or two examples here. So first example, decomposition or a reaction between 2NO gaseous plus F2 gaseous giving rise to 2NO2F. 2NO2F gaseous occurs in two steps. Okay. Step number one, NO2 plus F2 giving rise to, this is slow, NO2F plus F. F is an intermediate. Intermediates are always in these reactions. Some intermediates form as, that is cations, free radicals or anions, like that, carbocation or free radical, like that, and they occur in some reaction. They will get reacted in the another reaction. That means they will be destroyed in the reaction. Okay, they will not remain as the products. And second reaction will be, step 2 will be NO2 plus F giving rise to, this is a fast reaction, NO2F. So see here in the theoretical equation, what is the actual order of the reaction? It is 3. It is 2 with respect to nitrogen oxide and 1 with respect to F2. So that overall order of the reaction, if we calculate by the theoretical equation, it becomes. Now in these two steps, write the explanation here. Step 1 is slow step. Step 1 is slow step and is RDS. RDS full form, rate determining step. Step 1 is slow and into F2 raised to 1. Therefore, overall order of the reaction is 2 and not 3 according to stoichiometric equation. Okay, this is the conclusion. Stoichiometric equation. Don't go on the stoichiometric equation. You just follow up the rules. Okay. Second example. Decomposition of hydrogen peroxide, which is catalyzed in iodide ion in the alkaline medium. The reaction will be 2H2O2 in presence of I minus and alkaline medium 2H2O2 I minus in the presence of alkaline medium. Reaction will be 2H2O plus O2. So according to this reaction 1, 2, 3, 4, the reaction order will be 4. Okay. According to stoichiometric reaction, order of the reaction is 4 and step number occurs in write down the steps. Step number 1, H2O2 plus I minus, this is a slow step, giving rise to H2O plus IO minus. In this reaction, IO minus is the reaction intermediate which is formed in the first step and get destroyed in the second step. Okay. Step number 2, H2O2 plus IO minus, this is a fourth step. So H2O plus I minus plus O2. So see here, I minus is just formed here and here. It will be cancelled. And IO minus here and here it will be cancelled. Okay. So again concentrate on the slow step. Step 1 slow and it is RDS. So that rate determining step. So that you are writing the overall rate law as rate law R is equal to K into H2O2 raised to 1 into I minus raised to 1 N is equal to 2 not 4 according to stoichiometric reaction. Okay. So now next one. Units of rate constant of the reaction. Units of rate constant of the reaction. Step next heading. Units of rate constant of reaction. Units of rate constant of reaction. So in the assignment question, one question was that I have given you the unit of rate constant and asked you to calculate the order of the reaction. So if this column you study in detail, then it will be easier to you to get the order of the reaction from the unit of rate constant. Make 4 columns. First column is of reaction. Second column is of order. Third column rate is equal to a rate constant K is equal to rate divided by a relation for rate constant. How to relate the rate constant by the rate? That expression. Last column units of K. Okay. So make 4 columns. Then in the first column zero order reaction. Order of the reaction is 0. So that rate constant expression R divided by K raised to 0. So units of K, units of R will be moles per liter per second divided by moles per liter raised to 0. So that unit of rate constant will be moles per liter per second. Next, second one. First order reaction. Order of the reaction is 1. Relation between rate constant and rate. Relation between rate constant and rate is given by R is equal to K divided by K is equal to R divided by A raised to 1. So units will be, rate is having units moles per liter per second divided by A is having units moles per liter raised to 1. So that remaining unit will be second raised to minus 1. Next, third one, second order reaction. Second order reaction. Order of the reaction is 2. Relation between rate constant and rate is given by A raised to 2. So that again units will be moles per liter per second divided by moles per liter raised to 2. So here 1 moles per liter get cancels. Remaining mole raised to 1 divided by moles per liter into second raised to minus 1. Our unit will be mole raised to minus 1 liter second raised to minus 1. Similarly, last one, for the nth order reaction, order is n. The relation between rate constant and rate is given by A raised to n. So units will be moles per liter second raised to minus 1 divided by moles per liter raised to n. So that unit will be moles per liter raised to 1 minus n into second raised to minus 1. Remember this unit for the nth order reaction. Here I will wind up my class, and in the next class I will solve some problems and next part of the